So today we're talking about populations versus random samples. First, we're going to start, of course, with some definitions to write down. Please make sure that these get into your notebooks. And we're going to start off with parameter. A parameter is a numerical value, so we're talking some kind of number data that represents a set. Okay? So some kind of, whether I'm talking about mean or median or standard deviation or whatever, we're talking about a number that represents the data in a set. Next, we have inference. Inference is a conclusion reached using evidence and reasoning. So I hope that you've heard in the past that somebody has inferred something. That means that they've made an educated guess based on evidence that they've seen and, reasoning it out in their head. Next, we have a representative sample. A representative sample is a sample where the characteristics of your sample are similar to an entire population. We've talked kind of a little bit about this in class when we're talking about high school students in the United States. I can't just pick the 3 students that I run into in the hall and guess that they would represent all the high school students in the United States, right? My sample would have to be big enough and diverse enough that I could make a pretty good guess about the high school students in the United States from just the sample I took. Next, we have reliability. Reliability is the degree to which a study or an experiment performed many times would have similar results. So think about experiments in your science class. If you did the same experiment over and over and over again, would you get approximately the same results every time? Or would they be vastly different? Well, if the results are similar every single time you do the experiment, it's called a reliable experiment. If they totally come out super different every time, then your experiment is not reliable. So reliability has to do with outcomes. You have to have similar outcomes. Validity is the degree to which the results obtained from a sample measure what they are intended to measure. So let's talk about those high school students one more time. If I was doing a study on the heights of all high school students in the United States, and I did a study on their hair color, that study wouldn't be valid because that's not what I set out to study. And finally, biased sample. Bias is a huge concern in statistics, and especially with sampling. Biased sample is a sample where some information has a better chance of being chosen or included than others. So if you were doing that study of high school students and you just asked your 3 closest friends, that would be a biased sample because your friends were chosen because they were convenient, but that really wasn't a very good sample, right? So in medicine, business, sports, science, and a lot of other fields, super important decisions are really often based on statistical information drawn from samples. So a sample is simply a subset of the entire population, right? So look at these circles down here. If the big red circle contained all the high school students in the United States, I might only have time to interview those high school students that are in the small red circle, right? So the students in the small red circle would be my sample, and everybody in the big red circle would be my population. The wise selection of samples often determines the success or failure, of course, of those who use the information. It is possible to have samples that are more reliable than others, and it all comes down to whether the sample selected is actually random or not. Some super quick clarification before we move on. You have seen all of these different notations. We have different notations for mean. We have different notations for standard deviation. Mu is the mean for an entire population, so that's for all high school students. X bar that you see on your calculator is just meant to be the mean of a sample. With standard deviation, our original standard deviation notation is for a whole population, and S is the standard deviation of a sample. So just so you know, you only see X bar on your calculator. You don't see mu very often. But I wanted you to see the difference in formulas for standard deviation so that you know why there's two. X bar and SX kind of go together, and really the only difference is you're dividing by n minus 1, where in actual standard deviation I'm dividing by n. So I use mu in our original standard deviation notation. This is not something that you have to have memorized by any means, but I wanted you to see that there is actually a difference between the two, one for an entire population and one for a sample, so that you know why you're getting two different values on your calculator. So how well a statistic computed from a sample describes the population is going to depend in a huge way on the quality of the sampling methods used. And over the next couple of days, we're going to talk about different sampling methods. What you need to know for today, though, is the sample needs to be representative of the population. That's our representative sample. So we're going to practice with just a couple different types of sampling. Not necessarily in the video today, but we're going to use some sampling to get to know the following terminology. First of all, population. Population, of course, is all the people, objects, or phenomena of interest in an investigation. So if I'm looking at my high school student study, all the high school students in the United States would be considered the population. The sample, of course, is the subset of the population. Those are the people that I interview or talk to or measure or whatever. They're the people that I actually contact and take information from. A parameter is my numerical value that represent the data in my set. Now this is the numerical value that represents the entire population. So if I'm talking about student heights, the parameter would be my estimated average student height for all the high school students in the United States. And my statistic of interest is the physical measure that I did for the sample. Okay? And I'm going to use my statistic to predict something for an entire population. So let's take a look at three quick examples and determine what the population, the sample, the statistic, and the parameter are for each. So first we have Adam. He rolled a six-sided die 4 times and got a 5, a 5, a 3, and a 4. And then he computed the mean for his 4 rolls and used the result to estimate the mean for an entire population. So first, what population did he intend to measure for? Well, he's rolling six-sided die, so we're going to assume that he meant every single roll that ever was of six-sided die. The sample is what he physically measured. So his sample was his 4 rolls of six-sided dice. The statistic, now remember, statistic comes from his sample. S and S go together. Statistic of his sample was the mean of just his 4 rolls. And of course the parameter is what he's going to predict for an entire population. He's going to use his statistic to estimate the mean of all six-sided dice rolls. Let's take a look at this next one. So when you have a high level of what's called blood glucose, you might say that you either have or you're going to develop diabetes. So blood glucose, otherwise known as blood sugar, is typically tested in a doctor's office after fasting overnight, and the test result is called a fasting glucose level. So let's say a doctor wants to determine the percentage of his patients who have high glucose levels. He reviewed the glucose test results for 25 of his patients to determine how many of them had a fasting glucose level greater than 100 milligrams per deciliter. He recorded each patient's fasting glucose level in a table, of course. These are his 25 patient results. And we want to know what the population parameter, sample, and statistic is in this situation. So first of all, the population, he wanted to determine the percent of all his patients who had high blood sugar levels. So his population is all of his patients. The parameter, remember the parameter is what he's testing for the population, okay? So he's trying to figure out how many of his patients have blood sugar levels above 100. The sample that he tested, right, the numerical data that he actually tested was the blood sugar, the fasting blood glucose of all of his 25 patients. And the statistic of interest is the percent of those 25 patients that had blood sugar levels over 100. Remember, the two P's go together, population and parameter, and sample and statistic, the two S's go together. Statistic is what you're measuring from your sample, and parameter is your estimated value for an entire population. Finally, we have a math project, and Stephanie wants to estimate the mean and standard deviation of the points scored by the home and away teams in the NBA. She randomly selects one home game and one away game for each of 16 different NBA teams during the 2012 season and records their scores in a table. So let's talk about what the population parameter, sample, and statistic would be for her study. First of all, what do you think the population is? What was she wanting to estimate the mean and standard deviation for? For all teams in the NBA, right? So she's looking at all the possible NBA games. Her parameter, what she's wanting to study for all those NBA games, was the mean and the standard deviation for all the teams for their home and away points scored. Her sample that she selected to measure from were the points scored for two games, one home and one away, for the 16 NBA teams. There's way more than 16 NBA teams. That was just her sample. And the statistic of interest for her sample, she physically measured the mean and standard deviation for their home and away points. So in class, we're going to wrap this up by doing an activity called random rectangles. We'll do that very first of next class. Hopefully that'll finish defining the difference between population and parameter and sample and statistic. Make sure you bring your notes with you to class. I hope you have a great day, and I'll see you next time.